grade 12s to this great Monday, Mathematic Mondays, and you're here with me, Megs, and the first time I meet Lee, so welcome Lee, how
Hi,
are
Megan.
you?
Good to be here. No, I'm good, thank you.
I'm good, man. What are we doing today?
We're doing stats and probability, so I think those who've been watching the grade 11 have
11s.
already had a bit of a start. Now this is just going to be taking it a bit further.
Okay, thank you. So now I'm going to tell you quickly where to get all your information before Lee starts. Firstly, I'm going to be on the page, and that is facebook.com/learnextra, as well as if you want to sit with all the notes in front of you, be a cute little mathematician, then that is where to get mindset.co.za/learnextra. My mom told me, hi mom, I just want to say hi because I never really give her a shout out, so she deserves one today. And last of all, don't forget, can't you see I'm wearing a spring flower headband? Spring school, guys, it's going to be amazing from the 23rd to the 27th of September. It's going to be live shows, revision, exam revision especially, as well as us presenters and our favorite teachers. So don't miss out. It's going to be amazing revision for you guys, and that's where we learn more and learn extra. Over to you, Lee.
Great. Just to say, it's really such an advantage you guys have got that you've got this facility to actually learn so much by just looking at a television. What a pleasure.
Amazing.
I wish I'd had it in the dark ages when I was at school.
Dark ages, she lies.
Right, let's have a look. We're looking about statistics and probability. And I thought what we would do is we'd start by looking at a probability question first of all. Actually, yeah, statistics really, more than probability. So let's have a look. Now, I just hope my finger behaves itself because I usually have some fun in games with it. So here we go. So as I said, we're looking at typical exam questions. And the first one we're looking at is this one. I just want to get it here. The time taken for a pizza outlet to deliver a customer is recorded. The data is found to be normally distributed. Now, before we go any further, normally distributed is that like bell-shaped curve. And the good news is we also use that when we do your marks at the end of the year. They also get put on a bell curve because that's how large amounts of data are often a normal curve. So it says it's recorded. The data is found to be normally distributed with a mean time of 24 minutes and a standard deviation of 3 minutes. And there they've given you the symbols. They've shown you that X bar is the mean and that the sigma is the thing. Now remember, variance is related to standard deviation. I'm just going to mention it. Remember, variance is actually the square of the standard deviation, and I think probably Dina did that in the previous session, but we're going to carry on with it. Now you can see the bell curve looking at you here, and it says answer the following questions. So let's see what they ask. Now just something I want to mention before we move on, and that is to say that in actual fact it's always a good idea to read your entire question before you start. And to remember, if for whatever reason you can't do the A part, you can maybe do the B and C, and sometimes if they being very kind, which is often when they're marking at the end of the year, they would say, in the A part, they'd ask you something, and then B, they'd say, if your answer was blah, 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 and then the B part would happen. So sometimes, even though you might have missed the beginning part, you're better off. So let's have a look. Okay, the first question said, what percentage of pizzas are delivered between 21 and 24 minutes? So right, let's talk about this. First of all, there's the mean, and they told me that the mean was, let me just go back up there to see. The mean was 24 and the standard deviation is 3. Okay, so that's 24 and the standard deviation is 3. Now, what that means is if I go one standard deviation either side of the mean, then according to my drawing, 68% of all the results lie there. Which, because it's a bell curve and it's perfectly symmetrical, means that half of the 68% is on the left of the mean and half is on the right. So 68%, there'll be 34% on the left and 34% on the right. So right, if we look at this, it says, what is the percentage of pizzas that are delivered between 21 and 24? Now, what I like to do is I immediately say, okay, let's write out a few of these things. We can say 24, and the standard deviation was 3, so this would be 27, and over here would be 21, because it's one standard deviation away. And then the next one would be 30, with its 2 standard deviations, and 18. And then the last one would be 15, and this one would be 33. So, right, if I look at it, they're saying 100% of the pizzas are delivered between 15 and 33 minutes. That's according to the normal curve. And then they're saying to me that 96% are delivered between 18 and 30 minutes, and 68% between 21 and 27 minutes. Right, so what percentage of the pizzas are delivered between 21 and 24? I would go to my drawing. 21 and 24 is this bit. And remember what I told you? I told you that this mean divides this into 34% and 34%. Because it's symmetric, so it divides exactly in half. So the answer to this one, between 21 and 24, is going to be 34%. Okay, good. So the first question was nice and straightforward. Let's go to the next one. Next one says, what percentage of the pizzas are delivered between 15 and 27 minutes? Now, because I've already written on this curve so nicely, each of my standard deviations, it's going to be easy to ascertain that. So let's go to the drawing. Sorry, between 15 and 27, right. So between 15 and 27 is going to be all the way here along to there. Now we know that this divides the graph in half, this mean line. So we know that 50% of the people are lying this side and 50% that side. However, we only want the 34% here to get to 27. So the answer is going to be the 50 plus the 34 to give me the 84. So let's go back to the question, and we can now say that 84% of the pizzas are delivered between 15 and 27 minutes. That's not bad. If you're waiting for a pizza, I think that's fair enough. Now it says the outlet advertises that they will not charge for a pizza that takes longer than a certain time to deliver. If they want to give away no more than 2% of the deliveries, how many minutes should they allow for the delivery? And I'm sure you've all seen on different programs where the guys try and get it right to make them later than the stipulated time so they can get their pizza for nothing. Anyhow, the good news is they only want to pay for 2%, hopefully none, but at most 2%. So if we go back to our drawing, we know from our drawing over here that this would be 2%. So remember, that's 100, and that's 96, so this bit and this bit. Let's make up 4%, so there's 2% this side and 2% that side. And so I know that it's safe to say, and I shouldn't actually have moved that line, so apologies for that. Let's bring it back. Just need to change to the pointer. We know that we can safely tell them in this ad that we guarantee that the pizzas will be delivered in 30 minutes. If it's more than 30 minutes, we will give you your pizza for nothing, because that ensures that we will not pay for more than 2% of the pizzas. Right, so going back to the thing, let's see how we write up the answer. So we can say how many minutes should they allow for delivery. So the advert would go something along the line of 30. 30 minutes would ensure that only 2% of the pizzas would be later. And I know we have some different branches of pizza houses that are saying this kind of thing, and so you can get an idea what sort of statistics they've worked with in order to get that. All right, so now I think we've got that question under control. Just remember 68% within one standard deviation, and then we have 96 within 2, and within 3, 100%. So that gives you a good idea how it's spread. And in actual fact, what's interesting to mention at this point, when a teacher gives you an average for the class, it's interesting, but it only gets more interesting when they tell you the standard deviation. Because if they tell you that, you can see how many children are getting between marks. So say they said the average was 66, but the standard deviation was 10. Well, that's not such good news, because that means between 56 and 76, 68% are. And then you start going lower and a bit higher to get the other things. So it's not that bad, but it's not that good as compared to this, where it's only a 3 as a standard deviation. Right, let's look at the next question. Right, question 2 says the following. A recording company investigates the relationship between the number of times a CD is played on the national radio station and the national sales of the same CD in the following week. Now, I should imagine that is quite something that you could look at, because let's be honest, if you hear the record enough times, you think to yourself, I really need to go and buy that, because I'm enjoying this particular artist doing whatever they're doing. In the following week, the data shows was collected for a random sample. And while we're here, I'm just going to talk for 2 seconds about what they mean by a random sample of 10 CDs. The sales figures are rounded to the nearest 50. Random means they selected them without any criteria, in the sense of they're not taking all the R&B or all the rap or whatever. They're just taking a selection of CDs. Right, so let's have a look at it. Of these, number of times the CD is played and the weekly sales of the CD. Right, now the first question they asked me is identify the independent variable. So what do they mean by independent? Now, if we think about it, independent means that it doesn't need anything else to have it happen. So independent means the one that you start with that predicts the next one. So what are we trying to look at? We're trying to look at how often they are played, and then as a result, the sales. So the independent variable must be how often it was played, because we're trying to say that has to have some relationship to what happens later. So we can safely say the number of times the CD is played is the independent. Right, then the next question says to me, draw a scatter plot of this data on the grid provided below. The scatter plot showing the number of times the CD was played versus the CD sales. And then notice the heading, very good. And notice too that we've got our grid against how often it was played. Now what we're going to do is we're going to plot this, because I need to have the scatter plot in order for us to carry on with the question. So let me start putting it down. I'm going to pull the table down from the top. Hopefully it's not fixed. If it is, we're going to have some fun. I'm going to see if I can pick it up and... it's fixed. Okay, we'll just do it slowly. So what we're going to do is we're going to look at this, and I'm going to say I must plot 47 against 3950. Okay, so if I go down here, 47 against 3950. 3950 is over here somewhere, and 47 is out here. So I go to 47, I trace it up to 3950, which is just about here. And I definitely need to not touch the board with my hand. Right, so that's a point. So now I'm going to do that with all the points. And the good news is I think we're going to go to break first, and then I'll do it in the break so you don't have to sit and watch me boringly plot points. We can go straight to the questions after I've done it in the break.
Okay, if you say so, Lee. So we'll be back right after the break. Matrix, don't go anywhere. Welcome back, Matrix. I hope you had a good break. Got refreshed, had your glass of water, and it already is ready, please, and are ready to take on this next section. But before we start, I would like to tell you about a competition we have here. So, do you think you have a good teacher? Well, a brilliant teacher? A teacher that's influenced you, made your dreams come true? Think they were possible, inspired you? Then I suggest you enter them into the Stars in Education Awards. Do you know what that is? If you're thinking yes, if you're thinking no, I'm going to tell you where to get it. On our Facebook page, facebook.com/Learn Extra is where I'm going to be posting the link, because believe me, if I had to say the link, we'd be here until tomorrow morning. So I'm going to post the link. All you have to do, mindsetters, is click, enter your teacher's name. Like Lee would be a perfect candidate, if her students are watching, I'm just telling you. So I think, oh, and don't forget, don't forget spring school, guys, because I'm wearing my spring headband. If you don't know, I might have mentioned it before, but I'm going to tell you about it now. Spring school is from the 23rd till the 27th of September. We just entered into spring, even though it doesn't feel like spring because it's really, really cold. I think August is giving us a bit of a chill. So all the winter we didn't have before, we now have in our spring. But nevertheless, spring school's about revision, learn extra live shows, and guess who's going to be there? You guessed right. Of course, us presenters and your favorite teachers. We're going to be giving you exam revision, prepping you, live shows, and anything, all your questions, all your comments, and all your posts that you will need. So don't forget, let me tell you where to find all your information again. That is facebook.com/learn extra, where I'll be on the page right now with Lee, and post all your comments, guys, and as well as mindset.co.za/learn extra. So, Lee, are you ready?
Yes, I am. Thank you very much, Megan. Good to be back with you. And the good news is someone very kindly exported an electronic copy for us of the pointed plots pointed, so I don't have to go through this whole performance. So let's have a look. Here they are. You'll see we have put a green line in on it, but in actual fact, that we've done by a kind of gut feel. You know, I'm sure you remember that when you first learn about scatter plots, they talk about estimating where the best place is to put your line of best fit. And then the idea is you'd place your line, and I'm sure you've done it in other subjects as well, so that there's the same amount of data above as below the line. So we are going to show you now a proper way to do it using your least squares method. So you will see that happening shortly. But in the meantime, there are the points plotted. And you can see from the line that we've estimated that it's a nice positive gradient. And you can see if you look carefully that it is more or less positioned so that there's enough above and enough below. Now, the good news is that least squares, what it does is it starts talking about, in fact, let me use a pink one, the distance from the point to the line. Now, we're not going to get into the technical aspects of this, and if you really feel the need to, you can go off and grab yourself. Your textbook has probably got a really nice detailed explanation. What I want to show you is how we handle it in an exam situation. So right, going back, so there's our scatter plot. We already know that if we look at the green line, that in actual fact, that's a pretty good estimate of where that line of best fit will be. So right, let's go and look at what the question asks next after drawing the scatter plot. Right, so it said draw a scatter plot on this data on the grid provided below, which has been done. Right, let's go down to the next question, which seems to have vanished, which is not good news, but not to fear, I have got some notes here. Let me just grab them. Right, the next question says, determine the equation of the least squares regression line. So if we have a look at that, we want to find this equation, but we don't want just a guess. We want the real thing, and that is all done with your calculator. So I hope you've got your calculator with you, and you can follow through as we go. So let's have a look. Let's bring up the calculator, and I'm using the Casio, as you can see. Most calculators are more or less the same, so even if it's a little bit different, it's not the end of the world. So the first thing we have to do is we have to get to our stats mode. It looks like I need to use my finger, but that doesn't seem to be working either. This is turning out really well, guys. Let me just see why it's, oh yes, there we go. It could come up. So I want the stats mode, so I'm going to press my 2. And there I see it. Now I know that it's a line that I'm going to get. So I know that it's that number 2 over there. So I want to press 2 on my calculator, and up comes this. Now what I'm going to do is I'm going to enter the data. But the best way to enter it is to enter all the X's down, then to go back and do all the Y's. It's very important that you get your data matching correctly. So I'm not going to page up and down. I know this is not a very good thing to do on television, but I'm going to do it because it's just easier at this moment than touching the board and the calculator vanishes. So I'm going to now quickly go and put in the data. So I can see that X was the number of times the CD player is played. So I can literally go and put in these points. So I can go 47. Perhaps if I use my finger, I think it works better. Nope, it does not. Oh dear, come back calculator. Right, let's try again. Don't know why this board has been so stubborn today, but anyhow, it's giving me some character development lessons. Oh, now it's decided to just give me the 7. So let's just go again, 40. Nope, so started that 4 buttons. Oh, there you go, 47. Oh, right. You press the equals and it enters it in the calculator. Oh, this thing is going to bounce every time I look at it. And the next one is going to be 34, so I'm going to enter 34. Oh, that's the 4 is the problem. Everything else seems to be working well on the emulator. Just going to have to be patient with my 4. There you go. Press equals. Then it's 40. They show using 4 a lot, just when I don't want it. Right, and then 40 and okay, I think if I get rid of this, it might help. Let's try, yes, let's see if that helps us a bit. And there's another one, so let me just get, oh, then it just vanishes. That's great. Okay, I think that's fine. Now let's see if it works a bit better. So it's 40, then it's 34. Ah, that seems to be a bit better. Oh, sorry, guys, this calculator vanishes every time I look at it. And then the next one is 33. And the next one is 50. And the next one is 28. Okay, a bit tedious, but we're doing it. And then 53. Then 25. And the last one is 46. Oh, no, it's doing it to me again. Oh, dear me. Sorry, just bring it back up again. Okay, I don't want either of those, so delete, delete, delete. I don't know why this has been so insensitive, but it just is not behaving itself well. And if I press it too often, it decides to give me a hard time. So let's try again. And the last one was 46. Okay, and you press the equals. Now you, of course, go to the other side of the calculator. You take it up to the top and you enter in your Y values. Right, so with 47 we had 3950. And then we had 2500. And then we had 3700. Of course, it pays not to make any mistakes here, because you will get totally the wrong equation if you do. So then the next one is 2900. And the next one is 3750. Notice every time I enter, I put the equal sign in to get the data in. 2300. And then 44. This 4 is definitely sent to try me. Okay. Bring it up again. 4, 4, 4, 0, 0. Okay, and then the next one is 2200 and 3400. Sorry, guys, it's doing this to me all the time. I must just delete that. Doesn't like its 4, I'm afraid. 3400. Right, thank heavens the information is in. And now what we're going to do is we're going to find the least squares regression line. Now remember, the equation was shown to us. At this stage, I'd place all clear. The data's in there, so don't worry, it hasn't gone anywhere and I don't have to go back. We're looking for the equation, and it does help if one gets a color pen that shows up. We're looking at the equation y equals a plus bx, because it's a straight line. And we're now going to pull that calculator up and we're going to use it now to find it. So we go back to the calculator. I've pressed clear already, so now I go shift 1. There it comes up, and I want regression, which is number 5. And I want the a value, which is 1. And I just press the equals, and there it comes, 293,05. So a is 293,05. Right, going back to my calculator, I again clear it, because remember it's in there, stats, shift 1. I go to regression, which is number 5, and this time I want the B value, which is 2, which is 74,28. And that's my B value. So my regression line would be y equals A, which is 293, comma 1, if you like, just to round it to one decimal place, plus 74, comma 3x. Now, that is good news because that's fitting in around what we are discovering here. So if I look at this line, it does have a positive gradient, and the gradient is showing at 74, comma 3. And its y-intercept is 293, comma 1. And if you look over here on this end of the graph, you can see that, yes, that could well be 293, comma 1. So, yes, that line wasn't a bad attempt at putting a line in for us. Right, so let's go on and see what else they asked me. So that is my line of things. So, right, the next question says to me, calculate the correlation coefficient. Now, the good news is all the data is in the calculator. The correlation coefficient is your R value. So we would go back to our calculator knowing it's in there. We would clear it. We go shift 1. We would go back to regression, which is 5. And we'll see number 3 gives me my R value. And once I press the equals, there it is. It's 0,945. So I'm going to make it 0,95 just for convenience. So my R, and I'm going to put it in another color because we're going to talk about that in a moment, is 0,95. Right, so in the light of that, the next question says to me, comment on the strength of the relationship between the variables. In other words, the correlation coefficient. Now, what is the correlation coefficient? It tells you how the data is scattered on the drawing. So if you had a little drawing, and I'm just going to give myself a bit of room at the bottom here to give you some examples, that looked like this. Your R, in all likelihood, would be 0, or pretty close to 0, because there's no real correlation going there. But as soon as something like this started to happen, and maybe not as well as this one we've got here, you can see there is a bit of a correlation. This is a positive correlation. And probably your R you're looking at is more or less 0,3, round about there. It's not a strong correlation, but it is. But if it's 0,95, which is what this one is, then what I'm saying to you is the points are well and truly clustered on that line. So that would be an R of 0,95. Of course, if it was an R of 1, that would mean that the points are falling exactly on the line. Now, of course, this is also positive, and of course, you could get all the negative versions of this, but I don't think it's needed to go through that. I think you've got the idea there. So let's go back to our drawing one more time to look at it. And you can see if you look at that green line, those points are just about on top of the line. So it makes perfect sense that it is a strong correlation. So we can safely say a strong correlation. Right, great. And I think it's time for another break. Can you believe it goes so fast?
What? Really?
I know, Megan, I can't believe it.
Wow. Oh
what
my
do they say?
gosh.
Time flies when you're having fun.
Always with maths. Don't forget mindsetters. We'll see you straight after the break. Welcome back, grade 12s. Hope you had a good break. Got a stretch, got a glass of water, and you guys are ready to tackle the next part of revision probability. So, Lee, let's go.
Let's go. Right, let's have a look at this next question. It says there, let A and B two events in a sample space. Now, I think at this stage you're probably far enough down the line to understand what I'm talking there. Basically, what I'm saying to you is there's a whole sample of something happening, and I've got two events, A and B. But they tell me that the probability of A is 0,4, and the probability of A or B, now that's quite important, we're going to talk about that in a moment, is 0,7, and the probability of B is K. They want to know for what values of K are A and B mutually exclusive. Now, I can almost guarantee you that if they're going to ask you a question, they're going to ask you about mutually exclusive or independent events. Mutually exclusive, let's start with that first of all. Basically, what that comes down to in our speak is that the probability of A and B equals the probability of A added to the probability of B. Now, that is quite important. So what I'm saying to you is if I drew a little picture of this, then there would be no intersection between these events. So here's my A, here's my B, and there's no intersection. That's why the probability of A and B is the same as saying probability of A added to probability of B. Right, so let's have a look at this. And we go to the first question here, and it says to me the probability of A is 0,4. The probability of A or B, sorry, it should have been or, and I just happily wrote and, is 0,7. So together these are 0,7. So what they're telling me is this part out here is 0,3. Why is that? When we talk about probability of anything happening is 1. So if 0,7 is the events, then 0,3 must be none of those events. It might be other things, but it's not those events. Right, so once we're here, and they tell me that the probability of B is K. So in the light of it being mutually exclusive, that means that 0,7, and in fact, let me just tidy this up because it does sure look very miserable there. Back to the pens, A or B. Right, so then they're saying 0,7 is equal to the probability of A, which is 0,4, plus K, which means your K must be 0,7 minus 0,4. So it's going to be 0,3. Okay, so we've solved for K. So in this case, we're saying 0,3. Now they say for what values of K are A and B independent? Okay, so what is the rule for independent? Do any of you, I'm sure you by now you're screaming it at me. Well, the probability of A and B, or B, so I don't think it's or A, I always get confused at this stage, and I don't know why. It's the probability of A times the probability of B. So in that case, 0,7 is equal to 0,4 times K. And that's quite nice because now that means that K equals 0,7 over 0,4. And hopefully you all know from decimals, you just times the top and the bottom through by 10, and you get K is 7 over 4. Okay, you can do it any way you want to. You can use your calculator, and it'll give you that answer just the same. So just remember the two rules that are very important for our question. Right, let's go to the next question. I think that was the end of that one, if I remember rightly. Right, the next question talks about this. Now, I love this section. I love counting techniques, and there are something that you can make the questions so interesting. I mean, one of the things that constantly fascinated me was our number plate system in Gauteng. It had 3 letters of the alphabet, of course, excluding any vowels and excluding some other government, I think G or something, but there was one other exclusion. And then you had 3 numbers, and you could have repetitions. So you could have a number plate going BBB 777, for example, that was allowed. But we ran out of them in no time. So now they've changed it to 2 letters, 2 numbers, 2 letters. Now, it's a very interesting exercise to go and work out how many more number plates we can get doing that. But I'll leave that to you as a little challenge to think about.
Can you imagine sitting at home and going through all these number plates? Lee's given us a challenge.
I definitely think that at this stage you're probably thinking this woman needs to get a life. But anyhow, it's just interesting, and I love to watch how long it takes for a number plate to change. Now, how many unique codes are possible if the digits can be repeated? Now, very important when we're working with counting techniques is we remember to look for this. Can be repeated. That's very important because you get a very different answer if you can't repeat. So let's see what happens now. So we're saying it's a unique 3-digit code. So we know there are 3 digits. So what we're going to do is we're going to think to ourselves, how many ways can I select the first one? Well, there's 1, 2, 3, 4, 5, 6, 7 possible selections here. So I have 7 ways to choose the first number. Now, because I can repeat, I have 7 ways of choosing the next number and 7 ways of choosing the third. And if I remember rightly, the answer is 343 for 7 cubed. I suppose we should check it on the calculator. Let's do it. So it's going to be 7 to the power 3. I'm still in stats mode, which is not a good thing. I should have changed, but it's fine. It'll give me the answer just the same. And while we're here, I'm just going to change back to mode 1, which is the compute mode. All right, so we can see the answer is 343. My arithmetic does not let me down. And now we go to the next one. How many unique codes are possible if the digits cannot be repeated? So now, once I've used, say, the digit 1, I may not use it on the other 2 choices. So now I would do exactly the same thing I did just now. I'd have my 3 places. And I'd say, right, for this one I have 7 choices. But once I've made the choice of that, I only have 6 ways I can choose the next one, because I've used one of the digits. And now I've used 2 of the digits, so I only have 5 ways to choose that one. So that is the same as saying 7 times 30, which is 210. And you can see there's a huge difference. This answer was 343, and this answer is 210. So obviously, if you can repeat the digits, you have more possible ways of putting numbers together. If you can't repeat, there are fewer ways, which is why the number plates are fascinating, because you can repeat. So that gives you a lot more choices. If they made it that you couldn't repeat, it would be even more exciting. Right, so that takes care of that one. And now we go to the third question. Now it says, in the case where the digits may be repeated, how many codes are numbers that are greater than 300 and exactly divisible by 5? Now that is a very interesting question. Now, I love questions like this because you've got to be on your toes for them. So let's have a look at it. It goes like this. Remember, the digits were 0, 1, 2, 3, 4, 5, and 6. And the request is that the number be greater than 300. So we can have a 3 here. We could have 3 in the first place, a 4, a 5, or a 6. So we have 4 choices we can make on that first digit. We can't start the number with a 0, 1, or 2, because then the number will be less than 300. Now, what is interesting, it also has to be divisible by 5. So if it's divisible by 5, what do we know about the last digit on the number? Well, hopefully you all remember your rules of divisibility, and you would know that the last digit would have to have been a 0 or a 5. Now, obviously that's an interesting thing, because if I've used the 5 in that first place, then in the end, I can't have it in the front as well if I'm not repeating. But they said the digits may be repeated, so all is good for now. So I have 2 ways I can choose this particular digit. So I've taken 2 digits out of this, but I can repeat. So therefore, I have 7 ways to get that middle digit. Because there's nothing wrong with having 3, 3, 0. Or 4, 4, 5. That's also fine, because I can repeat. If it hadn't been repeated, it would have been a bit more exciting. Right, so now once we're here, we're going to say 4 times 2 is 8. 8 times 7 is 56. And you can, of course, use your calculator. So there are not many combinations that are more than 300 and divisible by 5. Okay, obviously, if we didn't have that little qualification and divisible by 5, there would have been more of these. Lovely question. Just while we're here, I'm going to just talk about the option that if they had said to me that I can't repeat the digits, how it would have changed things. Well, what would have happened now is I still would have only had 4 choices here. However, the last digit can only be a 0 or a 5. So I could have had some number ending in a 0 or some number ending in a 5. Now, if I had the 0 there, then I've used that 0 and it's out of the game. So now I can, 300, I can take 4 choices on that first digit. Remember, that's a digit, it's not a times. But now I may not repeat. So the 0 has been used, and 1 of those digits has been used. So 2 of the 7 are used, so I only have a 5 here. So there would be 20 ways I could do that. Over here, if I go here and I've used the 5, well, now I only have 3 ways to choose that one, because the 5 digit has already been used. Now, once I've done that, again, I've used 2, and I can't repeat, so it must be 5, so I would get 15. And in this case, I would get 35 options. So you can see that by not repeating, I get much fewer possibilities than if I can repeat. So that's why the number plates and those kind of things allow repetitions, because it gives you more chance of not getting someone's code off one of those little lock things on the gym lockers or whatever the case may be. Right, let's look at the next question. Right, this question tells us about complaints at a restaurant fell into 3 main categories: the menu M, the food F, and the service S. In total, 173 complaints were received in a certain month. The complaints were as follows. Now, what you do when you read a Venn diagram question, because this is a Venn diagram, you'll see just now why I'm saying that, you would read the whole thing through because it is important what we think. So we'd look at it. 110 complained about the menu. 55 complained about the food. 67 complained about the service. Now, if you added those 3 digits together, you would see that that is more than 173. So obviously, there's some people that complained about more than one of these things. So if we look at the next one, 20 complained about the menu and the food, but not the service. The next one, 11 complained about the menu and the service, but not the food. And 16 complained about the food and the service, but not the menu. And the number who complained about all 3 is unknown. Now, that is my favorite one because it does complicate the whole story. If you don't know the middle one, I saw earlier in the slot before, if you were watching, Dina was working with one where there was something unknown about both. But this one is in the middle of the whole story, so let's have a look at it and set it up. So it says, draw a Venn diagram to illustrate the above information. So the first thing we do is we put ourselves a little table out here, a little grid. We know this is the universal set, which we have been told is 173 complaints. We have 3 sets here. Service, menu, and food. What we know is we don't know who complained about all 3. We're obviously going to be asked to work that out, so I put an X in that place. Now, after I've put the 1 in the 3 thing, because I don't know it, I now go and look at them 2 by 2. So if I go for the ones that are 2 by 2, 11 complained about the menu and the service. So M and S together was 11. M and S was 11, but remember that it's 11 minus the X, because whatever's in there has already been counted. Let's get rid of that. I seem to be very good today at pressing things I shouldn't. Right, and then we go back and we look at the next lot of 2 things. And 16 complained about the food and the service. So food and service, 16. Food and service, 16. But again, we have to subtract the X because that would have been in that bubble effectively. Oh dear, that's really not a good idea to touch that. Okay, let's go back up. And then 20 complained about the menu and the food. So menu and food. Menu and food, 20. So we know this is going to be 20 minus X. All right, so we've managed to establish the overlaps, but we still have some other facts. We know how many people in total complained about each of these things. So let's go back there. They said 110 were about the menu. So what I normally do is in a bracket, I put the 110 there because I know that that whole circle must add up to 110. 55 about the food. And the last one is 67 about the service. So now what we do is we deal with each of these circles individually. So let's take this, and I'm going to highlight this circle in like this turquoisey color. And I know that all of that there must add up to 67. So what I could do is I could say 11 minus X, add it to X, add it to 16 minus X, plus something must give me 67. So effectively, if I add that up, 11 and 16 is 27. The plus minus X falls away, so I've just got a minus X. Yep, I think that's right. Is equal to 67. And I think it should have been a plus X. I've done something silly here. Let me just see what I've done. Oh, yes, that's right. And then, of course, the amount that I'm looking for would be the 67 minus the 27 plus the X. And if I do that, it's going to give me 40 plus X. So this is 40 plus X. What a lot of work to get there, but it's actually quite quite fun when you get into it. Okay, now I take the next circle and I do exactly the same thing. So now you've got the idea, so I'm not going to belabor the point. I'm just going to highlight this next circle yellow. And I'm going to add them up. So if I look there, 11 and 20 makes 31. Minus x plus x minus x is minus x. And I want to get the answer of 110. So 110 minus 31 is going to be 110 minus 31 plus x is going to be what's outstanding here. Right, so once I do that, it's going to be 79, I think it is, plus x. And yes, I've made a mistake. Let me just think. Yeah, that's right, I think. So it's 79 plus x. Right, and then I do the same thing for the other one, the remaining circle here. And this time I want to get 55. So if I add 16 and 20, I'm going to get 36. 36 or 55 is 19. And that's going to be 19 plus x. Now, of course, we're not finished yet, but we have drawn a Venn diagram. But usually at this stage, they would say to you, let's just see how they phrase it. They just said represent on a Venn diagram to illustrate the above information. Determine the number of people who complained about all three categories. In other words, solve for x. So what do we know if we go back to the information we had on our diagram? We know that if I add this circle to that circle to that circle, I must get 173. So now just be careful with this because we need to make this quite an interesting sum. So we have to go 40 plus x, that takes care of that one, plus 11 minus x, which takes care of that one, plus 79 plus x, which takes care of that, plus 16 minus x. Notice I don't double add. So once I've got it, I don't go back to it. And then I've got a 20 minus x. And I've also got, because I'm running out of space on that side, a 19 plus x. Now I know that all of that together must add up to 173. So what I've got now is a nice little problem that I can do. So, I mustn't go too high on that. All I do is bring up my calculator, and I'm going to actually just move it around a little bit. I'll bring it back up in a moment. So I want to add these together, so it's 19 plus 40. And I definitely need to raise it up a bit to get that O, plus 11 plus 79 plus 16 plus 20. And I get 185. If I add the x's, those two would fall away. Those two would fall away, and those two would fall away. Hang on, I seem to have lost an x somewhere. Yeah, there is an x in front there. Plus x equals 173. And I think I haven't made a mistake, I hope. So in actual fact, that should have been a minus x. Sorry, I don't know what I did there, but something silly. And not important. It's just a slip. And so I could say that x is equal to 185 minus 173, and that means that x is equal to, and if I subtract those, I would get 12. So x is 12. So I can answer at this stage and say 12 people complained about all three things. Now, if you're looking at it as the restaurant owner, 12 people being unhappy with all three is not a good sign for your restaurant, and so you should be a little bit worried. Let's see if there are any other questions on this. Yes. Determine the probability that a complaint selected at random from those received complained at least two of the categories, that is the menu, the food, and the service. So what I'm going to go back to now is the drawing, and I'm going to replace the x with the 12. So let's do that, and then we can get the actual figures, because we need to actually have a proper drawing now, so I can rub that out and put in the proper value. So that's now 12. And then this, come back, is going to be 16 minus things, 16 minus 12, which is 4. 20 minus 12 is going to be 8. I'm just going to overwrite it, and that's going to be 3. And then if I'm going to add 12 onto that, I'm going to get 81, 91 on that. So I'm being a bit untidy here. And 40 plus 12 is going to be 52. Okay, I'll just tidy it up a little bit with a eraser now that I've managed to whiz through a whole lot of these things. All right, and what have I left out? 19 plus x. That's going to be 19 and 12, which is going to give me, I merely lost the pen there. 19 plus 12 is 31, I think. Yeah. Right, so now they say, what is the possibility that they complained about at least 2? Now, if it's at least 2, it's 2 or 3 things. In other words, I'm only interested in these intersections here. So it will be the 12, it'll be the 4, it'll be the 8, and I seem to have erased that, which was very silly of me. Trying to remember what it was, but I think I can work it out. 52, 64, 68. All right, let's just take a guess and say it was 4. Then what I'd do is I'd add these all up. So I'd get 16, 20, 28. And then I'd say the probability is going to at least 2 is going to be the total amount I added up divided by the total number of people surveyed, and that will be the probability. I can ask you all sorts of things about probability.
I have a question for you.
That's good, let's hear.
Oh, Yolanda, I hope I said your name right. If you are given a data and they say calculate the standard deviation without being given a variance, how do you calculate it?
Okay, you have to, it depends if they let you use a calculator or not.
Okay.
So that just depends. If you're using a calculator, you would use exactly the same procedure I showed you on the calculator here. Let's pull it up. Usually it is calculator, so you don't have to worry. So you would literally go to your stats mode, like that. You would want to look at, in fact, I'm just looking and thinking this was not a good move. Anyhow, I'm being silly, I'm not thinking quick enough. But what you would do is you would go to the calculator, you would get your variance, you would enter your data, and it would work it out for you automatically. I think we've run out of time, so that's why I'm trying to talk really quickly. So I do apologize, but yeah, it can be done on the calculator. It can also be done manually, and there's a formula where you subtract from the mean, and you square, and you add it, and then you average it, and then you square root the standard deviation. If I had time, I'd quickly show you, but maybe our next one we can do that.
Thank you, Lee. Thank you, Matrix. We'll see you again soon. Mom, I'll be home soon, and we'll be right back after the following week. Bye, guys.